Hello everyone, welcome to Vyas Edification. In this session, we are going to discuss all NCERT and exercise solution related to chapter number 3, motion in a straight line, class 11. Clear? So, now for the detailed solution of all the questions concentrate on a screen. So, now dear student, we are going to discuss question number 3.1, and in this question it is given to you. In which of the following examples of motion can the body be considered approximately a point object? Clear? So, first of all, let us try to understand what is point object. Point object means what? When we can treat any object as a point object. When distance covered by an object is very large compared to size of an object, then we can say that object can be treated as a point object. For example, size of a locomotive engine is we can treat it as a point object compared to distance covered by the locomotive between two stations. Clear? We can treat sun and the earth as a point object because distance between sun and earth is very large compared to size of the planet. Yes or no? So, this is a concept of point object. Now, here four situations are given to you. Now, we have to choose which one is a correct, in which situation we can take object as a point object. Clear? So, in first situation, a railway carriage moving without jerks between two stations. So, clearly we can see because distance covered between two points or two stations, it will be very large compared to size of a railway carriage. It means we can treat railway carriage as a point object. Clear? It means this situation is correct. Now, second situation is given to you, a monkey sitting on top of a monkey cycling smoothly on a circular track. It means we can say size of a monkey is very less compared to distance covered by the cycle. Yes or no? It means we can treat monkey as a point object. So, this situation is also correct. Clear? If we talk about situation number C, a spinning cricket ball that turns sharply on hitting the ground. So, when spinning ball is hit on a ground and then turns, so distance covered in turning, it will be comparable with size of a ball. Clear? So, we cannot treat ball as a point object. It means in situation C, we will not take ball as a point object. Clear? Now, in situation number 4, it is given a tumbling beaker that has slipped off edge of a table. So, let us suppose we have a table and from the edge of a table, a beaker is tumbling. Clear? So, we can say because size of a beaker and the distance, or we can say the height through which the beaker that falls on a ground, that is comparable with the size of a beaker. Yes, it means we can say in this situation also we cannot treat beaker as a point object. Clear? So, first two situation we can treat object as a point object and last two situation it cannot be. Yes or no? So, this is all about this question. Now, dear student, we are going to discuss question number 3.2. And in this question, a position time graph is given to you for two children A and B, and they are returning from their school O to their homes P and Q respectively. Fine. Choose the correct entries in the bracket that is given to you. Clear? So, now you can see on this screen, we have this graph that is related to motion of two children and they are returning from their school to their home. Clear? So, now concentrate on a screen. Now, you can see, we can see this blue graph represent the motion of a children A and B graph, this represent motion of a children, this is Q. Clear? So, P and Q is the position of a home. Clear? So, this graph is given to you. So, let us suppose we can say, let us suppose this time is T1 and according to this graph, let us suppose this time is T2. Clear? Now, listen carefully. In first option it is given we have to find lives closer to the school, means if we compare children A and children B, so a children A or B, which one live near to school. Clear? Now, you can see directly from a graph, if we concentrate on the graph of a B, we can say let us suppose this is YB. Clear? This distance is YB and let us suppose we can say actually this is YA. This distance is YA, clear, and we can say this distance is, let us suppose YB, clear. So, now you can see directly from a graph the distance of home, or we can say distance of home of B is more compared to distance of home of A from school. Clear? It means directly you can say YB is greater than YA. Clear? So which children or which person lives near to school? Definitely we can say A lives near to school. So from here you can say, you can take on A lives closer to the school than B. Clear to everyone? So part A is clear to you. Now let's concentrate on part number B. Part number B. Now listen carefully. A and B start from school earlier than B. It means we have two children and which one started earlier. Now you can see at this point we can say we have time t equal to 0. So for children A at time t equal to 0 we have x equal to 0. Clear? And if we say for children B at time something, we can say at time t equal to 0 its x is equal to 0, but actually you can observe here we are having some time, but x is equal to 0 for children number B. Clear? Yes or no? So it means we can say if we compare children A and B, so children B started later compared to A from school. Yes or no? So we can say here A and B start from school earlier than B, so we can say yes, A starts from school earlier than B. Clear to you? You can see, let's suppose there is a situation like this. At this time, let's suppose you and your friend both are in a school. Clear? Let's suppose after completion of a school, your friend that returns to home, but let's suppose you stay for some time in a school, you are clearing your doubts, and after some time you will actually depart from the school to your home. Clear? The same situation we have here. Yes, so we can say A start from school earlier than B. Clear to everyone? So part number B is also clear to you. Okay. Now which one walks faster than which one? Clear? Now we can see if we consider on this slope, let's suppose this is theta B and let's suppose this is theta A. Clear? So we can say directly we can say theta B is greater than theta A. Clear? And we can say because this graph is given to you, this is xt graph. Clear? And slope of xt graph, this provides to you, if this is a distance, it provides to you speed. Yes or no? So our objective in this question is to calculate which one is having a faster speed. So definitely we can say when theta B is greater than theta A, then tan theta B it should be greater than tan theta A. Clear? It means we can say children B move faster than children A. Clear? It means we can say B walk faster than A. Clear to everyone? Now we are going to discuss part number 4. In part number 4 it is given A and B reaches home at the same or different time. Now you can see if we consider on this point, definitely we can say we have different times. Yes or no? And from here you can say T2 is greater than T1. It means we can say children A is taking more time compared to B. Yes or no? It means we can say A and B reaches home at different time. Yes or no? This is clear to you from this graph. Okay, now dear students, concentrate. And most of the place you will find solution that this graph and this graph they are matching at the same time, because but in NCERT this graph is given to you like this. It means here we can see the time is different. Clear? Now if we talk about part number E, overtakes on the road. Clear? Now you can say definitely we can say A started earlier than B, but B is moving faster compared to A. It means we can say B overtakes at a single point during the journey. Clear? And it reaches before A. Yes or no? It means we can say yes, B overtakes A on the road once. Clear to everyone? So this is all about this question. Now dear student, we are going to discuss example number 3.3, and in this example it is given to you a woman starts from her home at 9 am. Okay, walks with a speed of 5 km per hour on a straight road up to her office 2.5 km away. Okay, stays at the office to 5 pm and returned home by an auto with a speed of 25 km per hour. So initially we can say, let's suppose this woman is going to office by walking. Yes or no? That's why she is taking a time almost half an hour. Why? Because office is 2.5 km away and she is moving with 5 km per hour. Clear? But during the returning she actually coming with auto. So definitely speed will be more, time will be less. Clear? So what is objective in this question? Choose suitable scale and plot xt graph of her motion. So our objective in this question is to draw a xt graph, means distance time graph. Clear to you? So now let us try to analyze situation. So concentrate on a screen. Let's suppose this is a woman. Let's suppose this is woman. Clear? And let's suppose she starts from at her home at 9 am. Clear? Let's suppose this is the place where she has her office. Let's suppose this is office. Clear? In this question it is given to you, she walks 2.5 kilometer, and when she started its journey from her home, its speed is, it is given to you 5 kilometer per hour. Okay, now you can see here we are having uniform motion. Uniform motion means what? She is moving with uniform speed. Clear? So here we can apply one concept, S equal to ut. Clear? So we can see distance covered by her, this is 2.5 kilometer, and if we talk about initial speed, this is 5 kilometer per hour. So time taken we can say this is t. Clear? Or let's suppose you can take this is t1. So value of t1 we have 2.5 divided by 5. Clear? So this is equal to 1 by 2, and because this is given in kilometer per hour, so this is kilometer per hour. So we can say this is half an hour. Clear? It means we can say when she started at 9 am from home, it reaches to office at 9:30 am. Clear? So this is one calculation. Clear? Now she stays at 5 up to 5 pm in an office, and after that returns home by an auto with a speed of 25 km per hour. Now let's suppose if we talk about its returning journey. Its returning journey. Clear? So in returning journey we can see the total time taken we can calculate like this, S2 equal T2 equal to S over U2. Clear? Distance is same because she is again coming to home, so we can say total distance is 2.5 kilometer, but speed of auto is more, this is 25 kilometer per hour. Clear? So from here we can say this is 1 by 10 hour, or if we convert in minutes we can say she will come in 6 minutes only. Clear? Now what is our objective in this question is to calculate the graph, or we can say xt graph of the motion of the lady. Clear? So now we can see this is t2, this is 6 minutes, we have this is half an hour, so we can say this is 30 minutes. Clear? So it means we can say when she depart at 5 pm from office, she reaches at 5 and we can say 06 hour, means 5 pm and 6 minutes. Clear? So she reaches at home at this time. Clear? Now we are going to draw here xt graph. Clear? Listen carefully. So if we draw here xt graph, this is distance and this one is time. Clear? Let's suppose I am taking origin at 9 am. We can say 9, this is 10, 11, 12, 1, 2, 3, 4, 5. Clear? Yes or no? So let's suppose at time 9 o'clock she is at home. Clear? At time we can say at 9:30, because after half an hour she reaches to office, and we can say she is having uniform speed. So in uniform speed we will find xt graph, this is straight line. Clear? And we can say this distance covered, that is 2.5 kilometer. Clear? She stays up to 5 pm, it means position is not changing with the time up to 5 pm. Clear? And after that she returns with an auto at home, so we can say again distance decreases. So this graph will going like this, and here we will find this is 5, we can say 06 pm. Yes or no? So like this we can say this is xt graph for the motion of a lady. Clear to everyone? So this is the solution. Now dear student, we are going to discuss next question 3.4. A drunkard walking in a narrow lane takes 5 steps forward and 3 steps backward. Clear? Followed again by 5 steps forward and 3 steps backward. It means a drunkard person first going 5 steps in the forward direction and then again coming 3 steps in backward direction, again going 5 steps in forward direction, again coming to 3 steps in backward direction. So this situation is given to you. Okay, each step is 1 meter long and requires 1 second. It means first if we concentrate logic, then we can say when drunkard person is going first 5 steps forward, it means he covered total 5 meter distance and total time taken is what, 5 seconds. Yes or no? When he is again coming 3 steps backward, 1, 2, 3, it means now we have a displacement what, 2 meter, but total time taken is what, 5 seconds forward, 3 seconds backward. It means we have 8 seconds. So we can see total displacement we have 2 meter, but time taken is what, 8 seconds. Clear? So now again question is asking to you, determine graphically and otherwise how long drunkard takes to fall in a pit 13 meter away from the start. So let's suppose there is a pit after 13 meter and drunkard is going like this for 5 steps forward, 3 steps backward, and after some time it fall into dig. Clear? So total distance, or we can say total time taken by a drunkard person to fall in that pit. Now you can see, actually first we will try to solve this question by logically, then we will go for the graphical method as well as we will solve it. Clear? So we can say total displacement we have 2 meter and total time taken we have, this is 8 seconds. Listen carefully what I am saying to you. Total 8 seconds is taken by that drunkard person. We have a displacement 2 meter. Clear? So in the next 8 seconds again he will move next 2 meters. Yes or no? In next 8 seconds again he will move 2 meter. In next 8 seconds we can say again he will move 2 meter. So now we can say total distance or total displacement of the drunkard person we have 8 meter, but in how many times? We can say in 32 seconds. But what will happen in next situation? When drunkard takes 5 steps forward, at the time we can say 5 steps forward means what? We can say 8 meter distance already covered and 1, 2, 3, 4, 5. It means 8 plus 5, 13 meter. So we can say in next 5 steps total distance we have 13 meter. Clear? And at this position we have a pit. Yes or no? So the drunkard will fall in that pit. It means if he move total 5 steps, so total 5 seconds will be more. It means we can say the total time taken, this will be 37 seconds. So we have already solved this question logically. Clear? But let us try to solve this question graphically also. Clear? So correct answer we have, this is 37 seconds. Yes or no? Now listen carefully. Now let us try to solve this question graphically. So first I am drawing here a table. Listen carefully. Yes. So let's suppose here I am taking first this is time and this is x. Clear? So we can say when time t equal to 0, position x is 0. In next 5 seconds he is moving 5 meter. Clear? In next 3 seconds means total second we have, and we have displacement 2 meter because he is moving 5 steps in forward direction and 3 steps in backward direction. So total displacement we have 2. Clear? Okay. In next 5, so we can say this is 13. Clear? After that we will find 3. So this is 16. Then we find here total 5. So 21. Clear? Then 24. Clear? Then we find here 5. This is 31. Clear? Then we can see this is 30. This is 29. Clear? This is 29. Then we find here total 3. So this is 32. And next 5 we have, this is 37. Clear? So this is total time. But let us try to we can see write here value of x. So at time t equal to 0 we have x equal to 0. Clear? So how can we draw here a graph? So I am drawing here a graph also simultaneously. Let's suppose this is x and let's suppose this is we can say time t. Clear? I am taking here, let's suppose this is 0, 2, 4, 6, 8, we can say 10, 12, 14, 16, 18, 20, 22, 24, we can say 26. Clear? Actually I am drawing here like this. Let's suppose here I am drawing like this. This is x and this is t graph. Clear? I can write like this: 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Clear? Actually we need time up to 37 seconds. So I am writing like this: 34, 24, 26, 28, 30, this is 32, 34, 36 and 38. Clear? Here we are taking time in second. Clear to everyone? Now we need x up to 13 meter. So I am writing like this: this is 2, we can say 4, this is 6, 8, 10, 12 and let's suppose this is 40. Clear to everyone? Now we are going to draw diagram, or we can say the motion of a drunkard person. Clear? So concentrate on a screen. Now at time t equal to 0 we have x equal to 0. It means this is a position. Clear to everyone? At t equal to 5 we have x equal to 5. Means we can say we will find this position. Clear? So we can say here we will find graph like this. Clear? In next total time we have 8 seconds, but total displacement have 2 meter. So we can say now we have the graph like this. Yes or no? समझ में आ रहा बेटा? Clear? Yes. So this is all about this one. Now we can say in next 5 seconds. Next 5 seconds we will find here this is 7. Yes or no? So it means we have 13 and we have 7. So we can say this is 7 and we have 13 at this point. Yes or no? So we can say we will find graph like this. Clear? Now in next 3 seconds again he move in the 3 backward direction. So we can say this is 3, 7 minus we can say 3, this is 4. Clear? So now we can say in 16 seconds she will actually in 16 seconds drunkard person have at a 4 meter distance. Clear? So we can say like this one, this is the graph. Clear? Now in next 5 seconds we can say total distance we have this is 9. So 21 seconds we have 9. Clear? So first let's fill this table. Clear? So in 21 seconds we have total distance 9. In next 3 seconds we can say this is 6. Yes or no? In next 5 seconds we can say this is 11. Yes or no? And we can say this is 8. Yes or no? Because 3 step in backward direction and now we have 5 step in forward direction. So this is 13 meter. Clear? Now we can draw all these points in this graph. Clear? So we have already written 16, 4. Now 21 second and 9 meter. So we have 9 meter and 21 second. So this graph will be like this and this is 19. Clear? It will be look like this. Yes or no? 24 and 6 means this is 6 and 24. It will be look like this, because we are assuming drunkard person is having uniform motion because same distance is covered in the same time. Clear? That's why we can say x-ray graph we will find here this is straight line. Clear? Now we have 29 and 11 means 11 meter distance is covered in 29 seconds. So 11 and 29, it means it will be like this. Clear? 29 means this one. Yes or no? Like this. Clear? Now we have 32 second and 8 meter. So we can say this is 32 and we have 8 meter. It means like this one. Clear? And last we have 37 second and 13 meter. So we can say this is 13 second and we have 37 second. 13 meter and 37 second. Clear? So like this we can draw a XT graph of a drunkard person, and now you can say here we have drawn a table also, as well as we can draw this graph like this. Clear? You can easily draw this graph on a graph paper if you have. Clear? So this is all about this solution. Now dear student, we are going to discuss question number 3.5, and in this question it is given to you a jet airplane traveling at the speed of 500 km per hour ejects its product of combustion at the speed of 1500 km per hour relative to jet plane. What is the speed of the latter with respect to an observer on the ground? So now dear student, here we will find a concept that is relative velocity. Clear? So now for the solution, concentrate on a screen. Now let's suppose this is an aeroplane. Clear? Now this jet aeroplane traveling at a speed of 500 km per hour. So we can say this is velocity of a jet with respect to ground. This is given to you 500 km per hour. Clear? And let's suppose I am taking this direction is positive x direction. So I can write this value in a vector form also. Yes, I can write like this: velocity of jet with respect to ground, this is 500 IK. Yes or no? Now listen carefully. You can directly solve. If you are assuming one direction positive, other direction is already negative, so you can directly solve it. But let's suppose if we write in a vector form, we can write like this: eject its product of combustion at the speed of 1500 km per hour and relative to jet plane. It means we can say velocity of product of combustion with respect to jet. This is given to you 1500 km per hour. So definitely we know when the jet plane is moving in a right direction, logically we can see product of combustion will be going outside in a left direction. Clear? So you can assume any direction, but I am taking this direction. Clear? So if we write in a vector form, we can write like this: velocity of product of combustion with respect to jet, this is minus 1500 IK. Yes or no? Now what is our objective in this question is to find speed of latter, means speed of product of combustion with respect to ground. It means our objective here in this question is to find this one. Clear? So now how can we write? Actually we can utilize this one. Clear? We can say velocity of product of combustion with respect to jet. We can write like this: this is equal to velocity of product of combustion with respect to ground minus velocity of jet with respect to ground. Clear? Objective is what? Is to calculate velocity of product of combustion with respect to ground. So velocity of product of combustion with respect to ground, this is given by velocity of product of combustion with respect to jet plus velocity of jet with respect to ground. Clear? So we can write like this: velocity of product with respect to jet, this is minus 1500 IK. So minus 1500 IK plus velocity of jet with respect to ground 500 IK. Clear? So we can say this is minus 1000 IK. Clear? Now we can say our objective here is to calculate speed. It means we do not need any direction. So directly we can say here, magnitude of velocity of product of combustion with respect to ground, this is given by 1000 km per hour. Clear? It means product of combustion that is going outside from a jet, it will be look like it is going in a, because it is going in a left direction with the speed of 1000 km per hour. Clear? So correct answer we have 1000 km per hour. Now dear student, we are going to discuss next question. This is question number 3.6. In this question it is given to you: a car moving along a straight highway with speed of 126 km per hour is brought to a stop within a distance of 200 meter. Okay, fine. What is retardation of a car assumed uniform? It means we have to assume retardation is uniform retardation. Clear? And how long does it take for car to stop? Clear? So my dear student, actually here we have a concept. When we can apply equation of a motion, whenever any object is having uniform acceleration or uniform retardation, or we can say constant acceleration, at that time we can apply equation of motion. Clear? So in this question it is given to you that we have a uniform retardation, so it means we can apply equation of motion. So for solution, concentrate on a screen. In this question we can say a car moving along a straight highway. So let's suppose here we have this is straight highway. Clear? And let's suppose here we have a car. Let's suppose this is a car. Clear? This car is having initial speed, this is u equal to 126 km per hour. Clear? First we convert into meter per second, so we can write like this: this is 5 by 18. Clear? So we can say this is 8 times. Yes or no? No. We can say this is what if we cut we can say 9 2, we can say 9 1, and we have this is 4. Yes. So this is 4. Clear? And we can say this is 7. Clear? So we can say this is equal to 35 meter per second. So initial speed of a car we have 35 meter per second. Clear? Now it is given that it brought to a stop. Stop means what? It means after some time this car comes to rest. It means we can say if we have here a car, final velocity we can say this should be equal to 0. Clear? So definitely we are applying here brake so that this car is coming to rest. It means we can write like this: v square, this should be equal to u square plus 2as. Clear? Final velocity we have this is 0, initial velocity is given this is 35 whole square. Okay, we are taking this direction positive. Clear? Positive x axis. So we can write like this plus 2. Definitely here we will find retardation. Clear? And distance covered. Okay, covered distance is given to you, this is 200 meter. Clear? So we can write this is 200. Clear? So from here we can write 4000 AR, this should be equal to minus 35 whole square. Clear to you? Yes or no? So now we can say AR, this is given by minus 35 into 35 divided by 400. Clear? So from here we can say if we cut with 5, we can say this is 80, we have 7, we can say again 5. So this is 16, this is 7. So from here we can say minus 49 by 16. Minus 49 by 16. Clear? So we can say this is retardation, this is meter per second square. Clear? So this minus sign indicate what? This acceleration is acting in an opposite direction of a motion. Clear? So we can say retardation we are getting this is 49 by 16 meter per second square. Clear? Next objective here is to calculate how long does it take for the car to stop. Clear? How long? How long means here we will apply first equation of motion. So we can write like this: v equal to u plus at. Clear? So v equal to u plus at. Final velocity we have 0. Initial we have this is 35. Because this is retardation, so we can write like this: minus 49 by 16, and the time taken is t. So we can write like this: 49 by 16 multiply t, this is 35. So we can say this is 5 and we have 7. Yes or no? So from here we can say total time taken we have 5 multiply 16 by 7. Clear? So t value this is given 80 by 7 and in second. Yes or no? So this is time taken by a car to bring at a rest. Clear? So total time we have 80 by 7 second and retardation we have 49 by 16 meter per second square. Clear? Now student, we are going to solve question number 3.7, and in this question it is given to you two trains A and B of length 400 meter each are moving on two parallel tracks with a uniform speed of 72 km per hour in same direction. Okay, with A ahead of B. Clear? So condition is given to you like this. Let's suppose we have two parallel tracks. Clear? So let's suppose here we are having two parallel tracks. Clear? It is given two trains A and B of length 400 meter each are moving on two parallel tracks with a uniform speed in the same direction. Clear? A ahead of B. So let's suppose I am taking, let's suppose here we are having a train A, and let's suppose this is position of a train B. Both are going in a same direction. Clear? With a speed, this is given to you. So we can say VA and VB, this is given to you. Clear to you? And value is given 72 km per hour. So we can convert into meter per second like this. Clear? So we can say this is 4. Clear? And we can say this is 20 meter per second. This is also 20 meter per second. Okay, fine. A ahead of B. Okay, fine. The driver of B decided to overtake A. Okay, fine. Acceleration by and accelerate the train by 1 meter per second square. Okay. If after 50 seconds guard of B just passes the driver of A, it means train B has overtaken train A. Okay. So what is original distance between them? Now this train, you can see actually we can apply in this question concept of relative motion. So whenever two objects are in motion, we can apply concept of relative motion. Clear? So we can see we have here two trains and both are moving in the same direction with the velocity, clear, 20 meter per second. Clear? Now our objective here is to calculate value of x between them. Clear? So it is also given b accelerate by some amount 1 meter per second square and it overtakes train A in 50 seconds. Clear? So now actually we can write like this, velocity of b with respect to A. Clear? Because both are moving in the same direction, we can write like this, this is Vb minus Va. Yes or no? Now you can say both are having same, actually both are going in the same direction and both are having same speed. So we can write this is 20 minus 20. So relative velocity we have, this is 0 meter per second. Clear? Yes or no? Or you can say if we take here, this is initial velocity of b with respect to A, we can write like this. Yes or no? Clear? Now if we find relative acceleration, we can say acceleration of b with respect to A. So we can write like this, acceleration of b minus acceleration of A. Now train A is moving with a uniform speed, so we can say acceleration of A we have, this is 0. Clear? But what about acceleration of B? It is given in a question 1 meter per second square. So we can write like this, ABA, this is equal to 1 meter per second square. Clear? And let's suppose at any instant we are taking relative distance between B and A, this is x. Clear? So we can say distance between driver of a train A and guard of a train B, let's suppose at any instant we have x. Clear? Now you can see here relative acceleration is constant, it means we can apply equation of motion. Clear? So now we can write like this, as AB, this should be equal to UAB T plus 1 by 2 AAB, this is T square. Our objective in this question is to calculate value of x. So x, this should be equal to, this is 0 because relative velocity it is given to you 0, plus 1 by 2 into acceleration of A with respect to B, we have already calculated, this is 1 and this is 50 seconds. So we can say this is 50 square. Clear? From here you can write like this, 50 into 50, this is divided by 2. Clear to everyone? So from here we can write like this, this is equal to 1250 meter. Clear? So we can say when train B accelerated by 1 meter per second square and it just overtake train A. So when it started acceleration or when it started accelerate train B, we can say the distance between these two trains is given by 1250 meter. Clear to everyone? Yes or no? Now dear student, we are going to discuss question number 3.8, and in this question it is given to you, on a two-lane road, car A is travelling with a speed 36 km per hour. Two cars B and C approaches car A in opposite direction with a speed of 54 km per hour each. At a certain instant when distance AB is equal to AC, both being 1 km, B decided to overtake A before C does. Okay, what minimum acceleration of car B is required to avoid an accident? Clear? So first let's try to analyze the given situation. Clear? So now concentrate on a screen. In this question it is given to you, car A is travelling with a speed 36 km per hour in a particular direction. So first let's suppose here we are taking this situation. Let's suppose actually we have two lane. Clear? So let's suppose we are taking, let's suppose here we have a car A. Let's suppose this is car A. Clear? Or we can draw like this. Let's suppose we have car A, or just I am taking here an example. So let's suppose this is two lane. Clear? Here we have car A. Clear? And this car A is moving with the speed 36 km per hour. So I can write like this, VA, this is equal to 36 km per hour. We can convert into meter per second. So this is equal to 10 meter per second. Clear? So this car is going with the speed 10 meter per second in this direction. Now it is given two cars B and C approaches car A in opposite direction. So we can see, let's suppose here we are having car B and let's suppose here we are having car C. This car is going in this direction and this car is going in this direction, clear, and their speed is given to you 54 km per hour. So velocity of B or speed of B or speed of C, this is given by 54 into 5 by 18, clear. So we can say this is equal to 3, so we can write like this is 15 meter per second, clear. So speed of car C we have 15 meter per second, and here it is also 15 meter per second, clear to you. Now it is given in a question at a certain instant when distance AB is equal to AC. It means distance between A and B is same as the A and C, and this distance is also given to you, this is 1 kilometer. It means this is 1000 meter, and this distance we have 1000 meter, clear to everyone. Okay, now B decided to overtake A before C does, clear. So if we want to avoid accident, clear, if we want to avoid accident, first we will calculate in what time car C it reaches to A, and if we want to, if B car wants to overtake car A, so it has to overtake car A before that time, yes or no. So our objective in this question is to calculate minimum acceleration. So first we will find relative velocity of C with respect to A. So I am writing here velocity of C with respect to A in a vector form. I can write like this, velocity of C minus velocity of A. Now you can say, if you are taking sign into consideration, I am taking this direction as positive x direction, clear. So now we can say speed of C or velocity of C, we can write this is minus 15 meter per second. So I can say this is minus 15. You can also write this equation, this term in I cap or J cap also. So you can also write in terms of I cap like this. This is equal to 15. This is minus I cap minus velocity of A. This is given to you 10. This is I cap. So from here you can say this is minus 25 I cap. Yes or no? So if we just talk about magnitude, yani it means we can say speed of car C with respect to A, this is equal to 25 meter per second. So definitely we can say we have this uniform speed, clear. So we can calculate here total time taken by car C to overtake car A. So we can write like this, total distance we have 1000 meter and relative velocity we have, this is 25 meter per second, clear. So from here we can say we have total time, that is 40 seconds, clear. So in 40 seconds car C, we can say car C crosses car A, clear. So if we want to avoid accident, so it means car B has to overtake car A before 40 seconds, yes or no. So now what we can do, our objective here is to calculate minimum acceleration. So now we will apply, we will actually find first velocity of car B with respect to A, clear. So velocity of B with respect to A, we can write like this, velocity of B minus velocity of A, clear. Now we can see B is actually moving in right direction. So this is 15 I cap minus this is 10 I cap, clear. So we can write like this, this is 5 times of I cap, clear. So if we just find magnitude of this relative velocity, we can say here we are having 5 meter per second, clear. Is there acceleration is given to you? No, this is we have to find, clear. Distance is given 1000 meter, clear. So we can say our objective here to calculate acceleration. So we can write like this, SBA, this should be equal to VBA into T plus 1 by 2 ABA into T square, clear. Now it means first we will find in 40 seconds the car B has to cover this 1000 meter distance. So 1000, this is equal to VBA is what, 5 into time T is given to you 40 seconds, 1 by 2, this is ABA and this is 40 square, clear. From here we can calculate value of relative acceleration of B with respect to A, and this will be minimum acceleration, clear. So if car has to cross before C crosses this car A, the acceleration should be greater than ABA, clear. But our objective in this question is to calculate minimum acceleration, so we will find this ABA value, clear. So now you can write like this, this is 1000 equal to, we can say this is what, 200 plus, we can say this is 40 into 40, it means 1600, we can say this is 800 and this is ABA. Clear to you? So we can write like this, 800 ABA, this should be equal to 1000 minus this is 200. Clear? So from here we can write like this, ABA equal to, we can say this is 800 over this is 800. So we can say this is 1 meter per second square. Clear? So in this question, if we want to avoid accident, then acceleration of car B, it should be greater than 1 meter per second square. Clear to everyone? So correct answer we have 1 meter per second square. Now dear student, we are going to discuss question number 3.9, and in this question it is given to you, two towns A and B are connected by a regular bus service with a bus leaving in either direction every t minutes. Okay, a man cycling with a speed of 20 km per hour in direction of A to B notice a bus going past him every 18 minutes in the direction of his motion and every 6 minutes in an opposite direction. Find what is period of time t of a bus service and with what speed bus that is moving on a road. Clear? So this is a question that is given to you, and my dear student, this is a very important question. Clear? And very good question. Clear? So now listen carefully. Now let us try to first analyze the given situation. In this situation it is given to you, let's suppose here we are having a town A. Clear? And let's suppose here we have town B. Let's suppose this is town A and let's suppose this is town B. Clear? Let's suppose a person that is moving with a cycle. So let's suppose this is cycle and a person is sitting on a cycle and actually moving from A to B. Clear? So in this question it is given to you, A and B are connected by a regular bus service with the bus leaving in either direction after t minute. Clear? So from A and B, bus is actually leaving after t minutes. It means after t minute one bus that is departing A, and after t minutes bus B is departing to B, and it is towards A and towards B. Clear? So a man cycling with a speed of 20 km per hour, this is given to you 20 km per hour, and he noticed that a bus goes past him every 18 minutes in the direction of motion. Clear? So let's suppose when the bus is leaving from we can say from town A, it is having a speed V. Clear? So after t minute, after capital T minute, the bus is moving, the bus is actually going in regular interval of time from town A. Clear? So we see distance covered, can we find? Yes, distance covered by bus, we can say if it is having a uniform speed, we can say, because it is given in a question, we can write like this, this is V multiply T. Clear? This time is given to in a minute, we can write like this, this is in divided by 60. Clear? Now you can say if we find relative velocity of bus with respect to cycling. Clear? So we can write like this, because in first situation when bus is going from A to B, clear, in this situation we can say velocity of bus with respect to cyclist. Clear? This is, we can say this is V minus 20. Yes or no? Because both are going in a same direction, so we can say relative velocity can be written like this, and it is given in this situation when bus is going from A to B after 18 minutes, this person observed that after 18 minutes bus actually crosses this cyclist. Yes or no? It means we can say total distance covered in an 18 minutes we can find like this. Yes or no? And we can say every after 18 minutes, it means just after 18 minutes and another bus is departing from town A. Yes or no? It means we can write one equation like this, V multiply T by 60, this should be equal to V minus 20 multiply 18 by 60. Clear? Let's suppose equation number 1. Now let's suppose if we consider second situation, after every time t minute the bus is also departing from town B. Clear? And it is given in a question, and every 6 minutes the bus is actually crosses cyclist. Yes or no? It means now how can we write? Now we can write like this, because if we consider velocity of a bus with respect to cyclist, when the bus is departing from town B, it means we can say both are moving in an opposite direction, relative velocity added. So now we can write like this, V t by 60, this should be equal to V plus 20. This is relative velocity of a bus with respect to this cyclist, yes or no, and it crosses after 6 minutes, so we can write like this. Why we dividing with 60? Because we are converting into hours, yes. So now we have two equation and we have two variable, clear. So first we can divide, or first we can write like this, because left hand side is same, it means we can write right hand side is also same, clear. So V minus 20 and 18 by 60, this should be equal to V plus 20 and 6 by 60. So we can say 60 and 60 is cancelled out, we can say this is 3, clear. So we can write like this, 3V minus 60, this should be equal to V plus 20, clear. So now we can write like this, 3V minus V, this should be equal to 20 plus 60, 20 plus 60. So from here you can say value of V, this is given by 80 by 2, this is 40 km per hour, clear. So speed of bus we have 40 km per hour, clear to everyone. Now next objective is to calculate the time period of a bus service, clear. So now I can write like this, if we put value of V in equation number 1, this is 40 into T by 60, this should be equal to V minus 20, V is equal to what, 40, so 40 minus 20 into 18 by 60, so we can say 60 and 60 cancelled out, clear. So 40T equal to 20 into 18, clear. From here you can say this is what, 2, we can say this is 9, so we can say after 9, actually we can say after T equal to 9 here, clear. So from here you can say after 9 minutes, T value we have 9 minutes. So after every 9 minutes we can see the bus is departing from town A and town B, clear. So now you can see like this, we can calculate first speed of a bus and time period of a bus service, clear to you. So correct answer we have 40 km per hour and we can say this is 9 minutes, clear to everyone. Now dear student, we are going to discuss question number 3.10, and in this question it is given to you, a player throws a ball upward with an initial speed of 29.4 meter per second. Part number A, what is direction of acceleration due to upward motion of a ball? Okay my dear student, actually you know one concept, motion under gravity is the one of the best example of a motion in a straight line with a constant acceleration, yes or no. When we throw a ball in a vertical upward direction, acceleration due to gravity act in a downward direction, and when we free fall any object, then again acceleration due to gravity act in downward direction. It means you can say acceleration due to gravity always act in vertically downward direction, clear to everyone. So now we are going to discuss question this one. Part number A is given to you, what is the direction of acceleration during the upward motion of a ball, clear. So listen carefully, a player throws a ball upward with an initial speed 29.4 meter per second. Let's suppose here we have a ball and we are throwing a ball in vertically upward direction with 29.4 meter per second, clear. First part is given to you, direction of acceleration. So whenever we are throwing a ball in a vertical upward direction, acceleration due to gravity always act in a vertical downward direction, and it is having magnitude 9.8 meter per second square, and direction we have vertically downward, clear to everyone, clear. So this is the answer of part number A. What are velocity and acceleration of a ball at highest point of its motion, clear. So let's suppose this ball is going from this point A to point B, and let's suppose at point B we have highest point, clear. So we can say this is highest point, clear. So at point B we have highest point. Highest point means what? Highest point means we can say here we will find velocity, this is equal to 0, and what about the acceleration? Acceleration remains same, this is equal to minus g. If we are taking upward direction positive, then we can write like this, acceleration equal to minus g meter per second square. So this is value, clear. So the velocity at maximum height we find this is 0 and acceleration equal to minus g, or we can say if we talk about in terms of magnitude, this is equal to 9.8 meter per second square. Clear to everyone? So this is answer of part A and part B. Clear? Now actually we have two more part of this question. So now if we concentrate on part number C, if we choose x equal to 0 and t equal to 0 to be the location and the time of a ball is at highest point, means actually we are throwing a ball in vertically upward direction with speed u equal to 29.4 meter per second. This is given to you. Let's suppose this ball reaches to the point B, and this B is the maximum height, or we can say this is the maximum height that B can travel. Clear? So let's suppose we are taking this point as our origin, clear, or our reference. So it is given here, you have to take this x equal to 0 and t equal to 0. Yes or no? Now listen carefully. And it is also given vertically downward direction is positive x axis, means we will take this direction is positive x direction. Okay, fine. Now what is objective of this question? Clear? It is asking here, give the sign of position, velocity and acceleration of a ball during upward and downward motion. Okay. Now you can see, if we find the position, sign of position, upward, if we talk about upward journey, clear, in upward journey you can see actually the ball is here and ball is moving like this. It means because this is positive x, so we will take here position we have, this is positive, clear. And what about velocity? Clear, because velocity vector in this direction and this is opposite to be opposite of a vector that you have assumed positive. It means we can say velocity vector we have, this is negative. Yes or no? And what about acceleration? Because you are assuming downward direction, vertical downward direction positive, so we can say acceleration is positive. Yes or no? So this is the sign for upward journey, clear. But if we write here downward journey, downward, so if we consider for downward journey, means let's suppose this ball is at the maximum height, now the ball is moving in a downward direction, so we can say the position is positive because ball is going in a positive x direction. What about velocity? Velocity is also positive. Why? This is also positive because when ball will be here, it is moving in a downward direction and velocity vector is also in the same direction as you have assumed positive, clear. And acceleration positive, it means all are positive. Clear to you? So this is all about sign, or we can say this is all about part number C, clear. Now part number D is given to you. Part number D is given to you. To what height does the ball rise after long? How long does the ball return to the player's hand? Clear? So now we can say when we are taking to what height ball rise, clear. So let's suppose we are taking this ball, this is the position A, initial velocity is given to you 29.4 meter per second, clear. And our objective here is to calculate this maximum height, clear. So let's suppose this is position B, and at position B we know V equal to 0, clear. Now we know, let's suppose we are assuming upward direction positive, so in this case we can assume upward direction positive. It means we can say when ball is moving in an upward direction, it is actually moving under the influence of gravity, so acceleration is constant, so we can apply equation of motion. So V square equal to u square plus 2as, clear. At maximum height we can say this is 0, we can write like this, this is 29.4 whole square plus 2, this is minus 9.8, clear. Because we are taking upward direction positive, so acceleration due to gravity always act in downward direction. Yes, and we can say let's suppose this distance is h, clear. From here you can write like this, h, this is given by 29.4 divided by 2 into 9.8, clear. Now you can say this one is what, we can say this is 3, yes or no, and from here you can say 4.7, clear. So if you calculate, you can write like this, this is 1, clear, we have 1 or this is 44.1 meter. Clear? So maximum height is given by 44.1 meter. Next objective here, after how long the ball returns to the player hand. Clear? So first we calculate here by using equation number 1. Equation number 1 we can write like this: V equal to U plus AT. So V equal to U plus AT. At maximum height, final velocity we have 0, initial velocity 29.4 minus 9.8, and this is T1. T1 is actually what? T1 is time of ascent, means total time taken by body to move from A to B. So time of ascent is given by 29.4 divided by 9.8, and this is equal to 3 seconds. Clear? Now what is our objective? Objective is to find total time when the player again catches this ball. It means if we consider that viscous force is absent, at that time of ascent is equal to time of descent. Clear? So now we can write like this: total time taken by player. Clear? So we can write total time. Clear? So total time we can see this is equal to 3 plus 3, so total 6 seconds. Clear to you? So this is all about this question. Now dear student, we are going to discuss question number 3.11, and in this question it is given to you: read each statement below carefully and state with the reason and example if it is true or false. Clear? So in this question it is given a particle is having one dimensional motion. Now we have to check out of the 4 which one is true and which one is false, and also we have to provide here a suitable example. Clear? So now we are going to discuss first part number A. Clear? Now listen carefully. In this part it is given to you a particle in one dimensional motion with 0 speed at any instant. It may have non-zero acceleration at that instant. So my dear student, you know, is there any example where we find speed at any instant this is 0 but we have non-zero acceleration? Yes. So let us try to understand that situation. Let's suppose we have a ball. We are throwing a ball in a vertically upward direction, and we know as the ball is moving in an upward direction, its speed decreases. Clear? And at the maximum height we will find velocity, or you can say speed, this is 0. So when we have speed 0 at maximum height, is there any acceleration is 0? No. The acceleration that is at maximum height of the point, this is acceleration due to gravity, and this is written by, we can say, g meter per second square, and it always act in vertically downward direction. Clear? So it means we can see, let's suppose we have this ball is moving with certain initial velocity u in an upward direction. So let's suppose it reaches up to the maximum height, this is b, we can say this is a, and at this we have initial velocity, this is 0. Clear? It means, sorry, final velocity we have, this is 0. But what about acceleration? Acceleration, this is acting always in a downward direction, and we can say this is equal to g meter per second square. So we can say at maximum height we find velocity or speed of a particle is 0, but we have non-zero acceleration. Clear? So from here we can say part number A we have true. Yes or no? So this is a true statement. Clear? Now we are going to check part number B. A particle is having one dimensional motion with 0 speed. It may have non-zero velocity, not possible. Why? Because we know velocity, this is actually indicated by magnitude of velocity. Yes or no? So when magnitude of velocity is actually is speed, we can say that magnitude it never be 0. So we can say 0 speed, it may have non-zero velocity. Wrong. Whenever we have non-zero velocity, it means definitely we will find here a particular value of a speed. Yes or no? It means we can say this statement we have false. Clear to everyone? Yes or no? Okay. Now third statement we have, with constant speed must have 0 acceleration. Yes, we can say when a particle is having one dimensional motion, let's suppose a particle is moving in a one direction. Let's suppose we are taking, let's suppose here we have an object, and let's suppose this object is moving in this direction. So we can say this particle or this object is having one dimensional motion and it is having u, this is constant. So whenever we have constant speed, it means we can see acceleration. Acceleration is given by this is du by dt when this speed is a constant and direction is also not changing. So we can say acceleration of this particle, this is 0. Clear? Because particle is moving in a straight line, that's why I am saying the speed is a constant, so we can say acceleration is 0. Clear? It means we can say part number C, this is also a true statement. Clear to everyone? Now we are going to discuss part number D. In this statement it is given with positive value of acceleration must be speeding up. It means if we have acceleration positive, particle always have increasing speed. Clear? So we can say this statement we have false. Why? Let us try to understand this situation. So let's suppose this is the position of an object. Clear? And let's suppose I am taking this position as origin. So we can say this is 0, 0. Clear? Let's suppose initially particle is moving in the negative x direction. Clear? And let's suppose acceleration is acting in a positive direction, or we can say this acceleration is actually retarding motion of an object. Clear to everyone? So we can say we have this acceleration positive, but we can say this velocity we have negative. So it is not always necessary whenever we have acceleration positive, we always find speed or the velocity of an object that is going increasing. Yes or no? It means we can say when we find that object is always having increasing speed, when acceleration of an object is acting in the direction of a motion, we find acceleration is always actually giving the increase in the speed. Yes or no? It means you can say in the situation if we want to increase speed, definitely acceleration should also act in negative direction. Yes or no? So it means we can say acceleration should act in a negative direction, velocity is also in negative direction, so acceleration it may be negative, and when acceleration is negative here, we can say particle is having increasing speed. Clear to everyone? So we can say here we have two true statement, two false statement, and we have already understand all the given situation with the help of example 2. Clear to everyone? So this is all about this question. Now dear student, we are going to discuss question number 3.12. And in this question it is given to you, a ball is dropped from a height of 90 meter on a floor. At each collision with the floor, the ball loses 1/10 of its speed. Plot the speed time graph of its motion between t equal to 0 to t equal to 12 seconds. Clear? So now concentrate on a screen. So if we consider given situation, a ball is dropped from a height of 90 meter. So let's suppose I am taking here this situation, let's suppose this is a ball, and let's suppose here we have a floor. Clear? Let's suppose initially this ball is at a height, this is 90 meter, this is given to you in a question. Clear? And it is dropped, it means we can say initial velocity is 0. Clear? So acceleration this is acting on this body is g meter per second square in vertically downward direction. Clear? Now after striking or after collision with the ground, this ball loses 1/10 of its speed. Fine. Plot the speed time graph of its motion between t equal to 0 to t equal to 12 seconds. Clear to everyone? So now listen carefully. First here, what is our objective? First we will find total time taken by this body to strike the ground. Clear? So now you can say in the case of free falling, this body is going under the falling under the influence of a gravity. So we can apply equation of motion. Clear? So I can write here like this, as equal to ut plus half of at square. Clear? So let's suppose I am taking this direction is positive. You can take any direction positive. Clear? So let's suppose I am taking here this direction positive, or you can take, let's suppose I am taking this is negative. Clear? Or better, if we draw here, let's suppose I am taking here this direction positive, it will be comfortable to you. Clear? So we can say total distance we have from this point A to we can say B, this is equal to 90 is equal to, because this is a case of a free fall, so we can say initial velocity we have 0, 1/2 into 9.8 into total, let's suppose time taken is t1 square. So finally we can write like this, T1 square, it should be equal to, we can say 90 multiplied to divided by 9.8. Clear? From here you can write like this is 4.9. So T1 square, this should be equal to 90 upon 4.9. Clear? So if we remove decimal, we can write like this is multiplied with 10. Clear? So we can say T1 square, this should be equal to 900 divided by 49. Clear? So we can say value of T1, this is given by 30 by 7 second. Clear to you? And if we divide, we can say 7 4 28 we have, so we have 2, so approximately we can say this is 4.3 second. Yes or no? It means we can say total time taken by a body from A to B, this is 4.3 second, or we can say 30 by 7 second. Clear? Now can we find the velocity with which this ball strike to the ground? Clear? Again we can apply V equal to U plus AT. Clear? V, this is our objective V1. Initial velocity we have, this is 0 plus we can say 9.8 and multiply, time is what, 30 by 7. So we can write like this 30 by 7 second. Clear? From here you can say this is 10, this one and this one cancel out, and this is 14. Clear? So V1 value is given 42 meter per second. Clear to everyone? It means when this ball strike to the ground, it will have a velocity 42 meter per second. Clear? Actually you can also see, if we just write this expression of velocity, expression of velocity in terms of time, we can say this is equal to 9.8 times of t. Clear? So directly you can see in this region from 0 to 4.3 second, we can say y is, or we can say velocity is varying with the time, this is linearly. Clear? You can see we can write like this, y equal to mx. Clear to everyone? Yes or no? It means, now can we draw here a graph? Yes, definitely. So first I am writing here important terms, important parameters that we have already find. I am writing here T1, this is equal to 30 by 7 second, or approximately we can say 4.3 second. Clear? And we can write like this V1, this is equal to 42 meter per second. Clear to everyone? Yes or no? Yes. Now listen, if we draw here a graph, because our objective in this question is to draw graph between speed and time. So let's suppose here we have time in second and this is V in meter per second. Clear? Time is given to you in second. Yes or no? So this is given to you in second. Clear? So from here you can say, if we have time 0, from 0 to 4.3 second, let's suppose here we have, this is 30 by 7 second, up to which we have a linear curve, and we can say here we are having speed, this is 42 meter per second. Clear? So now we can see from O to this point, directly we can say this is a graph between t equal to 0 to t equal to 30 by 7 second. Clear to everyone? But in this question it is also given that after striking to the ground 10% of its speed, this loses. Clear? So we can say loss of velocity, we can say this is equal to 10% of 42 meter per second. Yes or no? It means we can say this is equal to 4.2 meter per second. Clear? So when this ball strike to the ground and again rebound in an upward direction, we can see initial velocity we have 42 minus 4.2. Clear? So from here we can say this is equal to what? 37.8 meter per second. Clear? U equal to 37.8 meter per second. Clear to you? Yes or no? Yes, exactly fine. Clear? Now here we will find the total time taken by a body to move from ground to a maximum height. Clear? Definitely we can say it will not reach up to the same height because now its velocity decreases. Clear? So we can write like this, V equal to U plus AT. We know when this ball reaches a certain height, we can see its velocity is 0. We can write like this because we are taking downward direction positive. So this is minus 37.8 plus we can say 9.8 multiply, let's suppose T2. Clear? So from here you can say T2, this is given by 37.8 divided by 9.8. Clear to you? Yes or no? And from here we can find approximately, you will find this answer 3.9 second. Yes or no? So if we draw this in a graph, you can see at this time, actually now this speed is decreases and this speed is decreases to 37.8 meter per second. Clear? And after 3.9 second, the velocity of that body becomes 0. It means we can say this is 4.8 second. If we add 3.9 second, so we can say 3.9. We can say this is 8.2 second. Yes or no? So from here you can write like this. The velocity of this ball becomes 0 after total 8.2 second. Yes or no? Now you can say here we will find a negative slope. Why negative slope? Because if we write here general expression of a velocity, we can write like this: v equal to u minus gt. Yes or you can say we can write like this: v equal to minus u plus g into t. Yes or no? Yes or no? So we can say here you will find a negative slope. Clear to you? Clear? Yes, because this is also negative because ball is going in an upward direction. So v equal to u minus gt. We have negative slope of a velocity. Clear? That's why we are drawing a graph like this. Clear? And I am also writing here time t2. This is 3.9 meter per second. Now exactly we have to draw here a graph between t equal to 0 to 12 second. Clear? It means now we will move ahead. Clear? So now we can say initial velocity we have 37.8 meter per second. Yes or no? Because we can say this body is actually moving in the upward direction with a velocity 37.8 and total time taken to move in an upward direction, or we can say in time of ascent we have 3.9 second. Because if we are observing or if we are assuming the viscous force is absent or air drag is absent, the time of descent is also same. It means we can say if we add 3.9 second also, this body again reaches to the ground. Clear? It means we can say this body again reaches with the ground with the same velocity. Yes or no? And time is what? We have to add 8.2 plus 3.9 second. Clear? So 3.9 second means we can say this is equal to 12.1 second. Clear? So we can draw a graph like this between speed and the time. Clear to you? So I think this problem is very clear to you. Clear to everyone? Now dear student, we are going to discuss question number 3.13, and in this question it is given to you: explain clearly with examples the distinction between magnitude of a displacement, that is we know this is distance, over a interval of time, and the total length of a part covered by a particle over same interval of time. Clear? So now concentrate on a screen. Let's suppose I am taking initial position. Let's suppose this is initial position. Let's suppose you can say this is station number A. Clear? Or we can say let's suppose this is B. Clear? Let's suppose we are assuming a particle started its journey from A and it is moving in a right direction. Clear? Let's suppose it reaches up to point B and again coming to same point A. Clear? It means what I am doing, a particle is going like this and again coming to same initial position A. Clear to you? So if we find total distance covered by a particle, so we can write like this: total distance. If we find total distance covered by a particle, so we can say this is equal to AB plus BA. Yes or no? Or you can say this is equal to twice of AB. Clear? But if we find displacement when particle again reaches to its initial position, we can say displacement we have 0. Clear? So in this question it is given magnitude of displacement, means we are talking about distance over an interval of time and total length of a part. So we can say displacement is equal to what? We have 0, and total distance we have, this is twice of AB. Clear? So magnitude of displacement over an interval of time and total length. So actually we can say, because in this question it is given magnitude of displacement. Magnitude of displacement means displacement we have 0, so its magnitude is 0. Clear? And we can see distance covered. So distance covered we have, this is twice of AB. Yes or no? So directly you can say definitely distance covered here, it is greater than displacement. Yes or no? Yes or no? Clear to you? So distinction is simple. In displacement we will find the shortest distance between initial and the final position. Clear to you? Displacement is what? Displacement is the shortest straight line distance between final and initial point, where distance we can see it is the total length of a path covered. Clear to you? So we can see this is all about part number A. Clear? Now if we talk about part number B, magnitude of average velocity over an interval of time. Let's suppose particle is again coming to its original position after time t. Clear? So we can see if we find average velocity. Clear? So if we find average velocity, we can write like this: V average velocity. This is equal to what? Total displacement upon total time. Total displacement over total time. Total time. So total displacement in this situation we have 0. So we can say this is 0 by t and this is 0 meter per second. Clear? But if we find average speed, clear? So we can write like this: average V average speed. This is equal to total distance upon total time. This is total distance over total time. Total distance over total time. Clear? So from here we can say what is total distance. What is total distance? So we can say here we have total distance, this is twice of AB and it is divided by time t. Clear? So from here again you can say yes, average speed is greater than, we can say this is average velocity. Yes or no? Yes or no? So definitely it is given here, show in both conditions second quantity is greater than or equal to first. Yes? Okay. When is equality sign true? So when we can say displacement equal to distance, when a particle is having motion in a straight line and particle is not taking a U-turn, at that time we can say distance is equal to displacement, average speed is equal to average velocity. Clear to everyone? So this is all about this question. Now dear student, we are going to discuss question number 3.14, and in this question it is given to a man walks on a straight road from his home to a market 2.5 km away from a speed of 5 km per hour. Finding the market closed, he instantly turns and walks back home with a speed of 7.5 km per hour. What is number 1, magnitude of average velocity and average speed of a man over a given interval of time from 0 to 30 minutes, 0 to 50 minutes and 0 to 40 minutes. Clear to everyone? So now we are going to discuss each case one by one. So let's suppose first we calculate number 1, this is 0 to 30 minutes. Listen very carefully. Clear? So first I am drawing here a given situation, a man walks on a straight road. So let's suppose we can say here we have a home of that person. Clear? And let's suppose here we have a market. Clear? So a person walks on a straight road from home to market 2.5 km. So this distance is given to you 2.5 km. Clear to you? Okay. With a speed of 5 km per hour. So let's suppose person is going from home with a speed 5 km per hour. Actually he found the market is closed. He instantly turns with and again move with the speed 7.5 km per hour. Clear? So we have to calculate magnitude of average velocity from 0 to 30 minutes. Clear? Now listen carefully. If a person starts his journey from 5 km per hour and okay, can we find here total distance or displacement? Total distance this is covered by, total displacement covered by a person in 30 minutes. Yes, we can calculate. So we can write like this, because this is a uniform speed, we can write S equal to U multiply T. Clear? We can say, let's suppose I am taking this direction positive. Clear? So we can say U we have, this is 5 km per hour. Clear? And total time is 30 minutes, we can convert into R. So we can divide with 60. So from here we can say this is 2.5 km. Clear? It means person cover a displacement of 2.5 km in 30 minutes. It means person move from home to market. Clear? So we can say actually in this situation person is moving in a straight line and person is not taking a U-turn. Clear? It means we can say in this situation distance and displacement both are same. Distance equal to displacement. Clear? And here we have velocity, we have total displacement, this is 2.5 kilometer. Clear? So we can calculate here average velocity. So we can write like this: average velocity, this is given by total displacement upon total time. Total displacement we have 2.5 kilometer over total time. Total time we have, this is 30 minutes. 30 minutes means we can say 1/2 hour. So from here we can say this is 5 kilometer per hour. Clear? Now if we calculate average speed is given by total distance upon total time, because particle is not taking a U-turn in a given interval of time. So we can see distance is also same and time we have, this is half. So from here we can say this is 5 kilometer per hour. Clear to everyone? So I think part number A is clear to you. Clear to you? Yes. Now listen carefully. Now if we discuss part number B, in part number B it is given from 0 to 50 minutes. Clear? So I am writing here 0 to 50 minutes. Clear? So initially particle is going here this with the speed to 5 kilometer per hour. Yes. And here this is 7.5 kilometer per hour. Clear? Now listen carefully. Now we know from 0 to 30 minutes actually this person moved to market, but here the interval is given to you 50 minutes. It means in the last 20 minutes this person will move again in a left direction. Yes or no? It means we can see if we find total distance, you can see in first 30 minutes total distance covered we know this is 2.5 kilometer, and in the next 20 minutes we can find distance covered by a person. So we can write like this 7.5 into, because in 20 minutes we can write like this 20/60. Clear? So from here you can say this is 1/3 and this is again 2.5. So total distance we have 5 kilometer. Yes or no? But an interesting fact, you can see if we calculate total distance. So total distance means what? A person is going from house to market and again coming to house. It means total we can say displacement is 0. Yes or no? Because you are taking this 2.5 kilometer positive, because this is in positive direction, you can say this is minus 2.5. Clear? And here we have 0 meter. Yes. So we can calculate if we find here average velocity. So average velocity, this is equal to total displacement upon total time. This is displacement. Clear? So we can write total displacement upon total time. Total displacement we have 0 and total time taken 50 minutes. So we can write like this 50/60, this is equal to 0 meter per second. Clear to everyone? So now if we write average speed. Average speed means we can say total distance upon total time. Total distance we have 5 kilometer and we can say this is 50/60. Clear? So from here you can say this one and this one cancel out and we can say average speed we have 6 kilometer per hour. Clear to everyone? So this is all about second part. Clear? Now we are going to discuss part number 3. Clear? Now listen. In part number 3 it is given from 0 to 40 minutes. Clear? Now you can say in first 30 minutes a person, this is covering, person or particle, you can take anyone. So a person is covering from house to market distance 2.5 kilometer. Clear? And after 30 minutes, it means for the next 10 minutes person is going with the speed 7.5 kilometer per hour. Clear? So we can say total distance covered. Clear? So in first 30 minutes person is covering 2.5 kilometer and in next 10 minutes we can see person is covering 7.5 into 10/60. Clear? So we can see this is equal to 2.5 plus 7.5 divided by 6. So this is 2 and this is 2.5. Clear? So from here you can see we can write like this 2.5 plus 1.25 and this is equal to 3.75 meter. Clear? But if we talk about total displacement we have 2.5 meter is the total, but 1.25 meter in negative direction. So this is 1.25, we can say this is 1.25 kilometer. This is kilometer, my dear student. Clear to you? So now, dear student, if we find average velocity and average displacement, average velocity and average speed, how can we calculate? So we can write like this: average speed, this is given by total distance upon total time. Total distance we have 3.75 and total time is given to you, this is 40 minutes. Clear? So we can write like this: this is 40 by 60, or you can say this is 3 by 2 multiply 3.75. Clear to you? So if you multiply, you can write like this: this is we can say 15, we have 1, 22, we have 2, this is 11 divided by 2. Clear? So from here we can say this is 5.125. Clear? And this is kilometer per hour. Yes or no? 5, we have one left, so we can calculate like this. This is what? 5, we have one left, so we can say we have 6 to 5. Clear? This one. So this is value of, we can say, average speed. Clear? We can also calculate average velocity. Clear? So for average velocity we can write total displacement upon total time. Yes or no? So total displacement we have 1.25, our total time we have 40 by 60. Clear? So from here we can write like this: this is 3 by 2 multiply 1.25. So this is equal to, we can say, 3.75 divided by 2. So this is, we have 1. Clear? We have 1 left, so this is 8. Clear? We can say 875 kilometer per hour. Clear? So this is all about this part number 3. Clear to everyone? So this is all about this question.